Last month, a single research paper from Google wiped billions of memory chip stocks in 24 hours. Samsung, SK Hynix, Micron, all hit. The paper was called TurboQuant. Most coverage framed it as a Google breakthrough. However, the one problem with that story is that math was already published 2 years ago, not by Google. And Korean project just tested a completely different approach to get there. And before we talk about this one, the one thing most coverage gets wrong is that quantization is not one thing. It's a family, it's a group thing. One branch compresses model weights, GPTQ, AWQ, GGUF, Q4. I know you've heard all these names. The other branch compresses the KV cache. That's the model short-term memory that grows as you type. Kiwi, Higgs, Aqua KV, these have been around since 2023. TurboQuant is one entry in that second branch. Keep that in mind because everything in this video builds on that one. The core technique TurboQuant uses is random rotation plus codebook. You rotate the data to make it smoother, then you map the smooth values to a small dictionary of preset numbers, which saves memory. Sounds really clever, and it is. However, the catch here is Higgs published that exact recipe in 2024. Aqua KV took it further and applied that specifically to the KV cache, which is what TurboQuant claims to do. And both of these predate Google's blog post by over a year. So what did Google actually do? One thing, one bit correction trick called QJL. And 5 days ago, an independent researcher ran it end to end and said, in plain English, QJL doesn't seem to be useful in practice. And I'm gonna translate that for you. The one actually novel thing Google brought to the table might not even help. So Google's breakthrough on paper is a newer variant of technique that was already public out there. That's not even a paradigm shift. We're talking about an incremental research, which is a very fine research worth publishing, but not what the headline said it was. The stock crash was totally unnecessary. And this one, the English-speaking AI space completely missed. The KAIST professor on the TurboQuant author list, Professor Insu Han, went on Korean TV right after the paper dropped. He said his goal was to solve a compute bottleneck in the AI space, not to forecast hardware demand. In translation, the researcher himself said the stock crash was very wrong. Another Korean professor went public with the same point using an economics concept called Jevons Paradox, which means every time computing gets more efficient, total demand goes up, not down. So cheaper gas led to more driving, and cheaper GPUs led to bigger models, and cheaper KV cache is supposed to be leading to longer contacts and more concurrent users, which means more memory demand, not less. So the people in Korea who actually understood the text said the market was wrong on day one. The stock market crash was not necessary and should not have happened in the first place. Nobody outside Korea listened. Samsung and SK Hynix stock tanked anyway because the market revolves around US. And this one I read myself here. A Korean development team called Quantum AI built their own inference engine in pure C language. They called it quant.cpp. They read the TurboQuant paper, they just skipped the fancy math entirely and just used the delta encoding from 1990s video codecs instead. In plain English, delta encoding just means instead of storing every frame of a video, you store the changes between frames, which is the same idea applied to memory. Their readme.md claims near 0 PPL loss on a small model called small LM2. By the way, PPL, which is a short for perplexity, is just a score for how good a model's output is. The lower the number, the better the output. My take on this was, if it works, it's another receipt that TurboQuant specific math isn't the reason that this stuff works. So I wanted to test it myself on my M2 Pro 16 gigabits using their own verified model, small LM2, with the configuration they themselves benchmark. I did 4 separate attempts, 3 generation tests, 4 perplexity checks. Every generation unfortunately produced garbage. Every perplexity check timed out even before finishing. 0 of 7 attempts produced a usable result. Now, I'm not really dunking on these developers. Open source research is how we get better tech, and I really respect anyone shipping code. The broader point here still holds anyway. Higgs and Aqua KV, they already published the core technique 2 years ago. But here's the thing that this test proves that a paper alone cannot. When a paper drops, blog post explodes, stock prices move, and nobody actually ran it on the hardware you own. So the people who build the engines you actually use, what I'm talking about, Georgi Gerganov, the guy who built llama.cpp, the engine Ollama, and LM Studio run on, he looked at the flood of TurboQuant PRs coming at him and did the simplest possible version. He added the rotation to the existing quant types, got most of the memory benefit, and told the community, why don't you show me why the rest is worth it? And that was weeks ago. The rest still hasn't been merged. Now look at what happened with vLLM. They merged the full TurboQuant 3 days ago, and here are the actual numbers from their own benchmark. On decode-heavy workload, meaning the step where the model writes out its answer, TurboQuant runs at 35 to 43% of baseline speed. Let that land for a second because the headline said 8 times faster, right? The real merged code, on the other hand, runs at roughly half the speed and in exchange for more capacity. So the people running the engines, Ollama and vLLM, are built on already decided which parts of TurboQuant are worth it. And it's not the part that headline celebrated, unfortunately. So where does that leave you exactly? Here's what actually is important for your setup. I'm gonna walk you through 2 things here. First, whether TurboQuant would even help you if it's shipped in Ollama and LM Studio tomorrow. Second, what you can fix today without waiting for any paper. So this is my M2 Pro with 16 gigs of RAM, running Ollama with Quant 3.5, 2 billion parameters, the newest small model in that family. Probably none of you are running it because it's too small. And I want you to think of it like this. Your RAM is a room. Your model weights are the furniture. The KV cache is people walking into the room, and as the conversation grows, and at some point that room fills up and people sitting on top of each other, and that's when things start to break. And watch what happened as I crank the context from 16K up to 131,000 context, and which is the full context window this model supports. And at 16K, I'm using 4.0 gigs at 32, 4.8 at 64, 5.6 at 131, at 7.2 gigs. Notice something, I never hit a wall here, still at 100% GPU across the board, and on a 2 billion models, because I don't want to blow up my laptop, right? So on a 16 gig machine, even 131 context is pretty manageable. Now, here's the thing. If you're running bigger model, 8 billion, 14 billion, maybe you can even run 70 billion if you're capable. That story changes very fast. But for the model most of you are actually running, TurboQuant isn't going to save your life here because nothing is killing you yet. Let me show you the other half here. What happens when I turn on the thing you can use right now with Ollama flash attention equals 1, Ollama KV cache, type equal Q8, 0, Ollama serve, which is the same setup and same model, same prompts, but now I've turned on the flash attention and 8-bit KV cache instead of 16-bit using 2 environment variable, all free and working today. And here's the result. At 16K, I'm at 4.3 gigs, 32K, 4.6, 64K, 5.2, 131K, 6.5 gigs. And at max contacts, baseline was 7.2 gigs, right? Optimized as 6.5, 700 megabytes back in my pocket. It's not a life-changing number, but real free money, right? And here's the thing that really is important. The savings is going to scale, right? At 16K, the difference was 100 max. At 131 is 700 max. If I was to run this on 8 billion or 14 billion model, that same pattern would save me a lot more because the KV cache will become a bigger share of total memory as the model gets bigger. And one thing before you wrap here, who is TurboQuant actually for, given what we just saw so far? It's for people running 7 billion models on 24 gigs GPU. It's for cloud companies serving thousands of concurrent users on expensive instances. Is for researchers pushing 1 million token contact. It's not for you if you're running a 4 billion models on a MacBook. The math that caused panic in the stock market just doesn't apply to your laptop or on your device. And that's the whole problem with how this story got told. So the honest playbook, the verdict I think I have is you gotta measure first. If KV cache isn't your problem, you can ignore the hype. And if it is, you can turn on flash attention and 8-bit cache today instead of 16-bit. And when TurboQuant lands in Ollama in Q3 2026, you already know whether you need it or not. And I put the whole decision framework in a free guide today and links in the description. You can just sign up for my newsletter. It's all yours. One more thing before you wrap. The video isn't really about TurboQuant, although I talked about TurboQuant. It's more about a pattern. You know, I call this the paper versus production test. When a paper drops, the paper has legitimate incremental research, and just marketing turns it into a breakthrough. Financial media turns it into a stock story. Stock starts to tanking, analysts who don't even know basic economics make the crash really worse. The actual researcher goes on local TV and says the story is wrong. Nobody outside the country hears him, maybe because it was not English speaking country. And then 6 months later, the merged production code ships at half the speed, and the people who actually build the tool shrug and ship the simple version here. And this is going to happen again and again and again. And in a few months, a different pattern, a different panic is going to happen, but all same pattern. The paper versus production test is, I think it consists of 3 questions, which is who actually benefits from the hype, and what are the real world deployment numbers and not the blog post numbers, and who is the researcher and what are they actually saying when they're not on Google's marketing page. I hope that makes sense. So the tech usually works eventually, however the story around it almost always never does not. My name is Daniel Jindu, and I used to run AI info business that questions my morale every single day, and eventually I had to quit. Now I'm just giving away everything I know about AI for completely free, no gatekeeping. You can join my community for free, newsletter to get as much value as you can. You can take it all, just all I'm asking for is just comment down below to help me keep going. I think comment sections are very fun, but it's up to you, not necessary. And you can grab the memory diagnostic PDF in the description. Comment what your actual bottleneck is. I'll use that pattern in the next video because that's how our channel runs. You as I build, we all learn. See you in the next video.